So in this area, we probably have to accept whatever usable security the market provides for free. So essentially, what we've noticed that in this area, so we don't really have a high degree of sensitive assets, users are really not likely to pay for security mechanisms. Okay? So essentially, the upshot here is that we ought to be able to design systems that are able to empower the users to separate assets. Finally, there is a minimum expectation for the security of a system by users. Users typically want to have, at the minimum, feasible recourse after breaches, after security breaches. So what they like to have, we like to have some assurances that security breaches are confined, that they are able to recover from security breaches, and equally importantly, that the adversaries who cause the security breaches are accountable for their actions. In other words, that users can go for punishment, right? I mean, because basically security breaches without punishments will be essentially perpetuated for a long time. So this is what I think are axioms of usable security. In particular, simplicity is important, extremely important, that we cannot have tremendous expectations for the users. The typical users of computer systems are not you. You are probably very, very atypical in a small percentage or small fraction of 1%, and that most users do not think the way you do. And they are unable to understand the policies that we all think about in the academia. They really understand only very few very simple policies. Now, this doesn't mean that users are not intelligent. I mean, humans basically exhibit a large degree of practicality. It's just that if you face users with mechanisms that are out of their everyday life, they are unlikely to remember how to use them and make mistakes. Okay, so now let me point out some of the irrelevance of some of the traditional architectures. In particular, let me point out the relevance of virtualization, traditional virtualization for the client side. The client side is always much more complicated than the server side for obvious reasons. The client side interfaces with humans. So let's think in terms of the traditional notion of virtualization. So here is a view of virtual machine monitor architecture as explained in late 70s, early 80s. So essentially what you have a virtual machine monitor which implements some very rudimentary access control policy, namely some form of resource virtualization, and it basically provides login to the right virtual machine. It might provide audit. It might provide even a system security architecture interface, system security administrator's interface. So the virtual machines run user applications. What's wrong with this picture on the client side, not on the server side? Well, one of the things that happened in the early 70s to mid-70s, where in fact VM370 was a reasonably popular operating system, was that application developers, which were largely the same as the virtual machine developers and largely the same as the virtual machine monitor developers, broke separation between virtual machines and, of course, applications in various ad hoc ways. Some applications required communication with other applications on different virtual machines using shared memory, shared files, shared segments. Others only required some form of network-type communication. And all these breaches of isolation took different guises. So this kind of complexity in the communication needs of application, mostly driven by performance, caused all sorts of bugs. And this, by the way, has not really changed all that much. Secondly, the virtual machine and application separation was not really under exclusive user control. In other words, the user couldn't tell at any point which virtual machine was running on the user's behalf. So there was no way to figure out if there was an unauthorized switch between virtual machines, possibly caused by malware or possibly caused by an insider. So there was no trusted path for humans in the systems. There was some form of very rudimentary trusted path which was later invented for login. So in the mid-80s we started having, starting with 1986, 87, we started having one-time passwords. And that was okay for login. That was trusted path for login, but not for anything else. Not for any execution of any sensitive user code. What about credible assurance? Well, there was none of that because the virtual machine monitor was fairly large and impractical to verification. Now, in the early 90s, the DEC VAX VMM fixed much of that, but it did nothing for application-level security. In other words, security in applications that actually implemented policy. Nothing about diverse components in application, nothing about insiders administering those applications, and of course, nothing about internet access. Right? So clearly, these architectures were in some sense okay, but not for humans, not for the client side, to empower the client to have control over its computations. What happens now? Well, the picture has changed a little bit, and in fact, you have separation between virtual machines and application is broken in much more controlled ways. So, for example, you have device virtualization in a Zen-like architecture where you have a small virtual machine monitor or hypervisor, and I'm talking about type 1 systems. And the access policy that's actually enforced on controlled breaches of separation is actually implemented both in the VMM and in the root domain. Okay, so that's progress. However, we still don't have the virtual machines and application under exclusive user control. We still don't have things like trusted path or full determination as to which virtual machine is running. Credible assurances, well, still rather impractical. So, for example, if you look at the virtual machine monitors, the hypervisor sizes, you have probably around 160,000 lines of code in Zen, and probably another 10 million lines of code in the root domain. And if you talk about Hyper-V, which is the Microsoft virtualization system that follows roughly a similar architecture, you have about, or at least I should say, 650,000 lines of code in the hypervisor and about 14 million lines of code in what's called the root domain. So this, of course, both the root domain and the VMM form the trusted computing base. And what you notice that while we rearrange the components, the size is too large for any meaningful assurances. And of course, there's nothing in here about application security, about component security in applications, about insiders, and about the internet.